Hey guys, it's Greaves here. Welcome to our first video of AP Physics. All right, so last time we were together, we looked at mass spring systems horizontally. I gave you some homework problems. I'll post those online. All right, so let's continue. Let's take a look at a mass spring system vertically. Okay, so a couple things. Let's take a look. Suppose I have a ceiling, I don't know, something vertical. I'm gonna hang a spring. Okay, unstretched, let's just make that a 1.1 meter spring. There it is right there. Okay, well, what's going to happen if I take a mass, right, and I hang it right there? Well, what's going to happen to the spring? Well, I think you and I know, right, what's going to happen is it's going to elongate, right? So it was 0.1 meter, and I don't know, let's make it 0.12 meters. There it is right there, 0.1. Okay, so what happens here? You might think that gravity is going to come into play when we do mathematics. I'm not going to go through the rigor of the math, but to tell you the truth, it cancels out. Okay, so it's going to look exactly like we had before, which I'll tell you in a minute, right? So here I have this mass hanging from a spring, which was 0.1 meter. Now it's 0.12 meters. What am I going to do? I'm going to grab this. I'm going to pull it down just a little bit. So if I pull it down, right, let's elongate it. You know what? Let's do it another. Well, what did I elongate this? 0.1, 0.12. It looks like, you know, I have a 0.02 meter elongation, right, when the mass was hung there. Let's do the same thing. Let's pull this down 0.02 meters again, and we'll let go. What's going to happen? Well, it looks like, I think you realize that this mass is going to do what? Oscillate back and forth from my original position, right, to my right of 0.1 meter, right, down to 0.02 meters, right? So this guy is going to wiggle back and forth. Well, let's take a look at gravity again. What did gravity do? Well, all it really did is when I took that mass and put it on the spring, it kind of shifts the new equilibrium position. Let's call this now the equilibrium position, right, of my system. So gravity, all it really does mathematically is it's going to shift our equilibrium position from before, okay? The good thing about this, right, so here's my new equilibrium position, and my mass is going to oscillate back and forth, right, from 0.02 down, equilibrium position, 0.02 up, back and forth, back and forth, back and forth. Well, what's the good thing about this? The good thing about this is it behaves exactly, right, like a mass on a horizontal system, right? So everything that we did before is completely applicable, meaning F is equal to Kx, right? Period, right? V max, how I find positions about objects, where they are at certain times, right? So energy, etc. So let's do an example, okay? So here's an example, right? And I'll take you through just about everything on this one example. So suppose I have a mass, a spring I should say, right? And let's keep it at that 0.1 meter with nothing on it, right? We're going to take a mass, right? A spring I should say, right? Let's put a mass on it. There it is, right? It'll move it to 0.04 meters, okay? So what happened? Putting this mass on this spring shifted my equilibrium position, right? Down, right? There it is right there. So there is this mass just hanging on the spring. And we're going to grab it, pull it down again. So let's pull it down so it's another 0.04 meters. And there's my mass, right? There's my spring, right? And this guy is now going to oscillate back and forth, back and forth. So let's see if we can find a couple of things. Well, to do that, I'm going to have to give the mass, this object a mass. So let's call it 0.2 kilograms, 0.2 kilograms. Let me erase that and make that a little better so you can see. 0.2 kilograms, okay? Spring constant. Well, you know what? Let's find out. Let's do a whole lot here. Number one, let's find a spring constant. Well, what is the spring constant? All right, well, if this is, right, the same as before, I can just use my spring relationship. So the force on the spring is going to be equal to Kx. And obviously, the force on the spring now is gravity, which is mg, is equal to Kx. So just to let you know, paper here is scarce at my house right now. So I'm going to ignore units right now. We really shouldn't do that. For right now, we're just going to ignore those, right? So what do I have? 0.2 times, let's call it 10, is equal to K. And how long is my elongation? 0.04 meters. Well, to tell you the truth, luckily I did this problem already and I have all the numbers. So if I did this, we're going to get 50 newtons per meter. All right, there's the spring constant. What else can we figure out? I don't know, let's take it over here. Let's find out what the period is. All right, so period is going to be equal to what? 2 pi m over k. So 2 pi, mass, what's my mass? 0.2, right? And we just found out that my spring constant was 50 newtons per meter. Well, like I said, I did this already. So what am I getting here? I should be getting about 0.4 seconds. There's my period. What else do you think we can ask? All right, how about what's my Vmax? And by the way, where is the Vmax? Well, obviously, my maximum speed is always going to be at my equilibrium position, right? So how do I find Vmax? Well, like I said, I like to use energy for this, right? There's an equation that you can use, right? It's in the textbook, but quite frankly, I don't like memorizing that. I just like understanding a couple of concepts, right? So what do I have for Vmax? Well, what type of energy do I have at the bottom? Well, that's spring potential. Vmax, what do I have when I'm right here? Well, that's kinetic. So 1/2, what do I have here? Kx squared, 1/2 mv squared. Well, it looks like, because I can do a little slash and burning right there. So I have 50.04 squared is equal to 0.2 v squared. And doing some math, I got a Vmax of 0.63 meters per second. Well, what else can I say? Well, how about this? What is my velocity at 0.02 meters from my equilibrium position? And by the way, that would be above or below. Well, how am I going to do that? Well, what do I have? My potential energy, total energy at the bottom is going to be equal to my potential energy at this new position, plus my velocity my kinetic energy at that position. So 1/2 kx squared, 1/2 kx squared, plus 1/2 mv squared. Looks like I can do some slashing and burning of those guys right there. So what do I have? 50 at 0.04 is equal to 50 at what? 0.02, don't forget to square that. Plus, what do I have for my mass here? 0.2 v squared. Doing a little bit of math, I'm going to get 0.54 meters per second. Meters per second, that is, at that new velocity. And that kind of makes sense, right? Because it's slower than it was before. All right, so here's a good example of a mass spring system vertically. All right, I'm going to send you a couple of problems in the textbook for you to do, and then we'll do some more stuff tomorrow. All right, guys? Have a good day. Wash your hands. See you later.